Good morning, good evening, good afternoon, good whatever it is where you're located. Thanks for tuning in to the Daily Space Weather. I'm your host, Dan, aka smAsho. The coronal mass ejection watch continues, folks. So that's the first order of business. Secondly, we've got some missing data. We'll show you. And we've got some mid-Atlantic snow forecasted and some thoughts about what's going on with the state of affairs with snow, especially in the northern hemisphere. First thing we're going to do is look at the sun's colorized magnetogram. This is going to show you North Pole oriented magnetism in green, South Pole oriented magnetism in red. To see a couple of very small sunspots in the southeast. I think we may have actually seen a coronal mass ejection strike here, but most of the data is looking pretty normal, an indication that it's pretty minor, if indeed it is a coronal mass ejection strike. Next, we're going to go out to Lagrange point 5 after I mute my freaking phone to take a look at Stereo A's view of things to explain why we have an ongoing coronal mass ejection watch. So if you look at the view from Stereo A here, Lagrange point 5, looking at the sun in this sort of an orientation with the Earth off to the right. We see the coronal mass ejection that we covered yesterday, which happened late in the day on the 12th. So right here, you can see a little bit of ejecta. Some portion of that did appear to be Earth facing. May have already struck. We'll look at the telemetry momentarily. What we're talking about with a continued coronal mass ejection watch is we still see a lot of plasma out here and out here, which could release suddenly with no warning and no solar flare. The 10.7 centimeter radial flux, which is a good proxy for sunspot number, is at 81 solar flux units. There's the one-year chart courtesy of Solon.info. It also shows you the sunspot number, the AP index over the last year. So there's the radial flux graph of solar cycle 25 in the beginning of 25 and the entire cycle 24, sunspot number and radial flux progression. Next, how about an SDO video in 94 angstroms? It's a full disk movie, and we'll show you some more in-depth views of those active regions in the southeast by the end. A normal feature here at the Smash News Network. So yeah, we're going to go to HelioViewer. And here's a full disk image in 304 angstroms. And check out the large filament down there in the southeast. Quite a significant filament. And that may prompt us to make another video today, as well as some filamentary behavior in the southwest, below where it says Earth scale there. So quite a bit of filamentary activity going on. Again, coronal mass ejection watch remains in effect. Thanks to our patrons, the true source of funding for the content. Please consider becoming a patron. The address is patreon.com/smAsho. That's patreon.com/smAsho. Please consider joining at the $3 per month tier or higher, as the other tiers, $1 and $2 per month, will be gone by New Year's Day. Here's a 171 angstroms SDO video. And you can see that filament behavior in ionized iron as well as ionized helium, which we showed you in 304 angstroms. Let's get to some more stuff. Today's Smash Lights segment may or may not exist. We're not exactly sure whether we'll do one or not. It depends on what happens with other news stories. I would invite everybody watching the video to come join us at youtube.com/smAsho in 1 week and 36 minutes and 17 seconds from when we made the video, at 5:02 a.m. Eastern Standard Time, we'll be streaming live for the solstice, which will incorporate into the daily space weather video. It just happens to fall at the right time of day this time. So join us for that. It'll be a YouTube live exclusive. Thanks to our new subscribers, etc., everybody leaving comments and all that over at youtube.com. We greatly appreciate that. Visit our links, etc. Don't forget to press like and subscribe. If you're a new viewer, tell your friends and foes. Tell your science noobs and your science pros about the channel. Don't forget to check out our playlists. They've got a surprisingly low number of views here. smAsho.org presents The Sun. We've also got other playlists like the Smash News Network and recent live streams and so on, all available at youtube.com/smashomash, youtube.com/smashomash/playlists. And don't forget to visit our own website, smashomash.com. You can see all of the rest of our social media links up there, as well as links to the forum and the stores. Thanks everybody who's been purchasing merch. Again, tell your friends and foes about that. We're also on bitshoot.com/smashomash, and you'll see some exclusive content over there. We're currently streaming live to Twitch, twitch.tv/smashomash, and cheers to Smash staff for putting up with our activity and posting it all over social media, as well as on some of the social media that we don't even interact on yet, as we are all over the internet at Smashomash. So again, today's Smash Lights segment may or may not get produced. It's not determined yet, so stay tuned for that. We're going to look at one random object here. We're going to roll a 1031-sided die to get a number 284, and we're going to see where it lines up in the Neil Gorell Swift Bat X-ray Observatory. Number 284 is T-Pix, which is null. I don't know what that means. T-Pix, some kind of an X-ray source. And here you can see it's going all the way back to the year 2004, it looks like. Pretty consistent X-ray source. I have no idea what that is. If anybody would like to look that up, T-Pix. It's showing up here as null and null, so we have no idea what that might be. Some sort of a weird object perhaps we've discovered accidentally here at the Smash News Network. By the way, you can link to the smAsho stores at the Smash News Network. Our homepage is smashomash.com. If you come down here and you click Smash Store, you'll find this, which features a condensed matter motif. Why? Because condensed matter matters. And today's featured product is the condensed matter t-shirt. Yes, condensed matter. It's the gold standard of cosmology. Since the sun is the Rosetta Stone of cosmology, it seems a little bit important, as it will rewrite astrophysics, cosmology, and indeed geology and vast swaths of physical sciences, when it's more widely accepted that stars are made of condensed matter. Single segment plasma, as the electrons are free, but the nucleons are not, in a liquid metallic hydrogen soup. Yes, it's soupy. Next, we're going to look at cosmic ray flux. Here's the Apatity neutron monitor, as well as Barentsburg. Tiny uptick here in the past day. Nothing to write home about. And a downward trend over the past 30 days. Similar situation at Barentsburg. There's the data from that. Next, let's go farther south and look at Athens, Greece. One of the more quality neutron monitors, and there you go. There's the 30-day chart at Athens. Slight downward trend at the Athens neutron monitor. Next, we'll go even farther south to Mexico City. There's a 30-day chart from Mexico City. No need to comment on that. Nothing extraordinary happening there. And last, we'll look at Oulu, Finland, and DOMC, Antarctica. There's Oulu. Shrink that down so you can see the historic chart. Slight downtick over the past 30 days at Oulu, and there's DOMC Antarctica. A little more wild, but also a downward trend over the past 30 days. And that's today's cosmology segment. We wanted to keep it short and keep the space weather video short. Next, we're going to show you some missing data here in the real-time solar wind. Let me shrink that down one size there. There we go. So missing data here in the real-time solar wind. We see big fluctuations in the temperature as well as the speed, swinging around from 335 up to 372. Not a real big swing there. Current solar wind velocity 350 kilometers a second. Solar wind density 6.2 protons per cubic centimeter. Otherwise pretty uneventful there. KP index is at 0 for the past 9 hours. Those are 3-hour increments. And it looks like we're getting the finger here sometime yesterday. So here are the geospace magnetosphere movies, and we see some oddities here. Keep in mind the space weather modeling framework cannot be properly constructed unless we have all the data there. And so over the past 4 hours, we see some missing data. Nearly 2 hours of missing data. We'll show you in a minute. Here's the density. We just showed you the velocity. So there's the density. And it's looking pretty anomalous there. It's showing you high density in dark blue, low density in white. And here is the magnetohydrodynamic pressure. And I'm going to show you the missing data point in a minute after it refreshes there. From approximately 7:30 to approximately 9:30, we don't see data on this. And thanks to Mandy for giving me a heads up. So there you can see what's going on there. 7:35 until about 9:17, we see no data. And you can see the pressure switching from the bow shock side, the side of the Earth facing the sun, from the magneto-tail side. Actually, vice versa, switching from the magneto-tail to the bow shock. There you can see pressure in the magneto-tail side, which is the non-sun-facing portion, and then switching to the sun-facing portion. Nothing to write home about there. And the space weather modeling framework requires a lot of different data points in order to correctly create its model. So if you look at what happened here on the ground magnetic perturbations at the same time of day, there it is at 7:35. We see some changes in the Earth's B field over the North Polar region there, only the Canadian one, not the Siberian one, and perturbations over the South Pole. And then we see a global magnetic pulse happening right there. Indeed, some magnetism directly above my head. And for you new viewers, we're located right about here in Lehigh Valley, Pennsylvania. So just looking at this a little further here, looks like some serious magnetic induction possibly caused there. Maybe a small coronal mass ejection strike could explain something like that. But we do see significant magnetic pulses there around that time. So somewhat of an event happening there, at least magnetically speaking, around 9:30 Universal Time, somewhere between 7:20 and 9:30 Universal Time. Let's actually take a look at the polar view here. We don't always look at the polar view, but this could give us some insight. And you do see some perturbations there over the Siberian North Pole also. And that's enough geospace magnetosphere movies for one day. Welcome to the Neo-Renaissance. Welcome to the polar excursion. And there's the GOES proton flux flat. So no proton events happening, no major solar flares. There's a 3-day chart of the GOES X-ray flux. Here's a star chart. As we approach the solstice, nothing bright on the ecliptic right now, no Venus, no moon. Although we should see Venus rising shortly. Looks like it's a new moon. There's where things will be in 1 week in the solar system. And here's the GOES magnetometer. And we don't see a whole lot of stuff going on here, but we see an arc jet moment there. Perhaps the spacecraft shut itself down. And we are now in the South Pole current sheet. It looks like that would be my guess. Here's a view of the heliospheric current sheet polarity. North Pole shown in green, South Pole shown in red. This also shows you the potential field surface source line of stereo A and stereo B, which are located at Lagrange point 5 and 4 respectively. Keep in mind the data is about 2 hours old there and can change with absolutely no warning. 'Tis the nature of magnetism in space, folks. So here's a line of sight coronal hole field plot. Here's me vanishing. And this also shows you the B field. You can see some changes in the B field happening here. Some indications that the south solar polar field is looking pretty strong. And here's a line of sight field plot, which also shows you the solar polar fields in green and red. And lastly, we'll look at the coronal magnetic field plot, the magnetic field plot of the chaotic atmosphere of the sun. And this is showing you open potential field surface source lines in either purple or black, depending on their location. We see some closed lines there, some interaction in between the north solar polar field and the plasma down by the setting sunspot region in the southwest. And let's move on to more data, such as electron flux. We don't really see any charging hazards here. And there's been a reduction in the forecast for the electron flux. There's a 1-year chart, and you can see we're in a fairly nominal range here. And there is the relativistic electron forecast. Pretty flat forecast here for the next couple of days. And just let me check the life of the stream. We are good. Thanks everybody leaving comments, etc. Thanks for viewing live streams, live premieres, old videos, commenting on social media, etc. Here's a 3-day chart of the GOES electron flux. And the GOES 16 measures this data up at the F ionosphere layer. Here's a total electron content forecast. This will give you an idea of where GPS errors will be located. And nothing to write home about there. Some fairly regular anomalies. Yeah, regular anomalies. Yeah, we see the same old anomalies there. Some small ones over North America. And here's just a diagram of the Van Allen belts and where things like GPS satellites are located. That total electron content forecast is giving you an idea of the entire air column to where those GPS satellites will be, all the way down to the ground. And here's a diagram. Excuse me, here's a diagram of the atmosphere showing you the troposphere, where all your weather occurs, all the way up to the exosphere. And again, the GOES 16 is measuring the magnetism and the X-ray flux and the proton flux and the electron flux at the F layer of the ionosphere. Here's a visualization of the ionosphere. This one's courtesy of Bureau of Meteorology of the Australian government. And everything's looking pretty normal here on the ionosphere map to me. Let's bring up the latest image, which is at 9:30 Universal Time. Slightly charged up on the nighttime side there, especially in the southern hemisphere, as they approach summer. Next, we'll look at volcanoes to see that Etna is back at it. So some interesting Strombolian activity happening at Etna, lava flows and so on. A strong eruptive episode currently in progress, at least late night yesterday on December 13th. So a new flank vent has opened there. So an uptick, a significant uptick, happening at Mount Etna in Italy. Sicily, that is, which is part of Italy. Next, Fuego exploding, Sangay exploding, Revenador exploding, and Sabancaya exploding. Flight level 150, 220, 150, and 240, respectively. All producing ash plumes between 15 and 24,000 feet. Please do not attempt to pole vault any of the calderas. We need the views. Next, looking at earthquakes over the past 24, and we see two swarms here that are interesting. One in Western South America and one in the deep quake capital of the world, Oceania, north of New Zealand, around Fiji and Tonga. Deep quakes also kicking off, as well as this ultra shallow quake 100 meters above sea level, this one underneath the caldera of Mauna Loa. So, some deep quakes here. Here's a deep quake at Argentina. It's 200 kilometers deep and a 4.8 magnitude, which would be like a 5.3 if it was at the surface. A small deep quake strikes Dominica in the Caribbean, the Dominican Republic, on the island of Hispaniola. Small deep quake strikes Alaska, as well as a significant quake in the Aleutians, a 4.6 magnitude quake at 178.9 kilometers. I think the largest of the past 24 may have been this 5.3 at Papua New Guinea. Chile sees a deep quake at 4.3 magnitude of just over 100 kilometers. And then about a half hour later, a 4.4 strikes the Mariana Islands region. That 4.4 magnitude quake at 298 kilometers depth. Another deep quake strikes the Caribbean. A deep quake strikes Fiji. And I think that is the largest of the past 24. It's a 5.6 magnitude at over 520 kilometers depth. That one happened at 1:57 Universal Time. Here's a 4.4 at Argentina. Another deep quake there. Another deep quake in the Caribbean. Another deep quake at Tonga at a 5 magnitude. Another deep quake by the Fiji Islands. Another deep quake at Vanuatu. And another deep quake in the Aleutians. So that's a reminder, folks. If you're in an earthquake-prone zone, be prepared, as we're seeing a massive, massive drought of 7, 8, and 9 magnitude earthquakes. Those are the kind that generate tsunamis, and we haven't seen one for an extended period of time, although we did see a tsunami in the last major quake in the Aleutian Islands. It struck Hawaii and Alaska. So have a plan. Know which building facades may collapse if you're going to exit yours, especially in an urban area. If there's an old statue that looks like it's going to fall down, well, it might fall down when things start to shake. Next, looking at pressure maps. And we're expecting some significant snow here in the mid-Atlantic states. We'll get to it. So we're on windy.com looking at the pressure maps. Northern Pacific dominated by low pressure systems, as well as the northern Atlantic. And some high pressure zones there in the North Geographic Polar region, as well as over Asia. Let's advance this into tomorrow. There's where we expect pressure, according to the GFS forecast, to be at tomorrow at 1 p.m. Eastern Standard Time. There's the way pressure is going to be moving, according to the GFS. Next, looking at nullschool.net, we want to see what the jet streams are doing. And there's the jet stream scenario for the Western world. A pretty significant kink in the jet stream there over the central U.S. as we see a mixing of cold air from Canada and warmer air from the west. Here are the jet streams of the eastern world. And once again, we see a strong clockwise, low-pressure oriented rotation over Western Australia. If you're wondering where lightning is striking on a global scale, check out lightningmaps.org next time you hear thunder. Perhaps convince your friends and foes that you're Thor or something like that, in that you can actually forecast thunder by using lightningmaps.org. Hey, Manavgat. Hey, Manavgat. There's thunder rolling in. And here's the GO 16 lightning mapper. We don't see a lot of lightning except in the Atlantic Ocean, and not a lot at that. Next, looking at the Weather Underground U.S. Doppler radar map. Heavy storms there over eastern Virginia, southwestern West Virginia, Tennessee, and a band of stronger storms moving from Alabama into Georgia, as well as scattered snow all across the northwestern portion of the country and northern Pennsylvania. We'll show you the forecast for the mid-Atlantic states. And there you go. So looking at now an uptick. So now we're forecasting for about, looks like about 8 inches of snow here in Lehigh Valley, Pennsylvania. Again, SMASH staff and I are located right about there. So there you go. There's the forecast through Thursday at 1800 Universal Time on Thursday. And this is going to be more of a legit forecast now, as if you're looking out more than 3 days, it's probably too many days to forecast. Now we're just at like 4 days, a little under 4 days here. So that's the way that's expected to play out. And just so you know, I've been forecasting for less snow than the past 3 winters. So not to toot my own horn here, but you can see we're at a more of a normal amount of snow mass for the Northern Hemisphere. And just so you folks realize, the Boston through Washington, D.C. corridor received almost 0 snowfall last year, while the rest of the Northern Hemisphere received 2 standard deviations above the norm. The Northern Hemisphere also saw 2 standard deviations above normal snowfall for 2017 through 2018 and 2018 through 2019. So my forecast for the 20 through 21 winter is that we'll see less than 2 standard deviations above normal, and so far that one is coming true. So let's hope we don't get excessive amounts of snow again, as it affects things like crop growth. It affects growing seasons and so on. So we're just showing you the graph here for this winter. There you go. There's the Global Cryosphere Watch total snow mass for the Northern Hemisphere, excluding mountains. You can see actually we are right now on the average for this time of year, and the average is from 1982 to 2012. Here's what's going on in the cloud layer. And here's what's going on in the water vapor map. And we'll rock that back. There's the cloud layer. And there's the water vapor. And stay tuned for bonus features. Thanks for flying American Smashways. Please keep your head and arms inside the smash plane at all times. Here's what I saw during show prep. You can see this sunspot here, 2792. This one here, 2793. Should get a name. And there it is in colorized magnetogram. Those are both beta-class sunspots, although the umbrae are quite small. colorized magnetogram, and the intensitygram. And let's refresh those to show you the latest high-res image of that. There you go. Looks like some more activity rising here in between those two areas from a latitudinal perspective right there. Another active region looks like it's rising. Here's the intensitygram. And you can see that there are at least some umbrae associated with both of those areas. So that's the most up-to-date image we can show you. And last but not least, we're going to show you the rest of our HelioViewer movies. Here's 171 angstroms. Here's me vanishing. Help us to not vanish by supporting the channel via the links below the video. Don't forget to enter the promo code smAsho to save 10% through Christmas Day on all Teespring orders. Promo code smAsho at checkout will save you 10% through Christmas. And we're going to zoom in. Here's the 171 angstroms zoom of the southeast. A great view of that filament down there also. Coronal mass ejection watch continues. And here's the extreme close-up. And thanks everybody for tuning in. I've been your host Dan, aka smAsho Mash, welcoming you to the Neo-Renaissance. Wishing you a delightful day, and may that solar wind be at your back and that covidiously absent from your location.